In this video, we're going to talk about the degree of unsaturation. This gives us information about how many rings and pi bonds we have in our system. We need the number of carbons, the number of hydrogens, X, which is halogens such as fluoride, bromide, iodide, chloride, and the number of nitrogens. We're going to take those numbers and plug them into the equation. Let's do some examples. Here we've got cyclohexylamine. Our formula is C6H13N. We have 6 carbons. There's 13 hydrogens. We don't have any halogens, so that would be 0, plus 1 nitrogen. Let's do some quick algebra here. 6 minus 6 plus 1 is 1. The degrees of unsaturation for cyclohexylamine is 1, and this comes from the ring. Let's do our next example, 1,4-diacetylbenzene. This is from our lecture videos. We have 10 carbons minus 10. We don't have any halogens, and we also don't have any nitrogens. 10 minus 5 plus 1 gives us 6. We have a carbonyl and another carbonyl. That would be 2 degrees of unsaturation. We have a ring. That would be 3. And then we have 3 double bonds here in our aromatic ring. That would be 6. 6 total. Let's do allyl bromide. C3H5Br. 3 carbons minus 5 over 2 minus, we do have a halide here. We've got a bromide. Minus 1 over 2. We don't have any nitrogens. We're going to add 1. This gives us 3 minus 6 over 2 plus 1. 3 minus 3 plus 1 is 1. That comes from our double bond. When we get the degree of unsaturation for a molecular formula, this helps us figure out if we have a ring or a pi bond in our system. Notice we have 2 systems with 1 degree of unsaturation, which could be either a ring or a double bond. We will use this information as we solve proton and carbon NMRs and IRs for unknown compounds. By looking at this degree of unsaturation for our molecular formula, we get information about the structure of our compounds.